So take a look here. I have here powers of 2, right? So we are on page 8, everybody. So these are powers of 2, right? And if I have 1 as my exponent, so 2 to the power of 1, I know that'll be a 2. So increase the exponent by 1 each time. 2 squared is a 4. And then add 1 more to the exponent. 2 cubed, I get 8, right? But what happens in going from exponent of 2 to 3, my value went from 4 all the way to 8. I skipped through a whole bunch of numbers like 5, 6, 7, and so on, right? So what if what I was looking for was the exponent of 2 that will give me a result of 6? I missed that entirely, right? Like what I really wanted is 2 to the power of what gives you 6, right? So how do we answer that question? To answer that question, we need a logarithm. Okay? So a logarithm answers the question of what exponent of a given base will result in a specific value. All right? Okay, so for example, here I have 2 to the power of what is equal to 6, right? So if I was walking down the street and I saw that on a billboard, 2 to the power of what equals to 6, I would say to myself, oh my God, look, somebody's looking for the exponent of 2 that would give them a 6, right? Okay, now, if I was walking down the street and I saw this on a billboard, log base 2 of 6, right? If I just saw that, I would again look at that and say, oh my God, somebody's looking for the exponent of 2 that would give us a 6, right? So these mean the same thing. So this is what this lesson is all about, finding that exponent. So now, a logarithm is always a what then? An exponent, right? So now, if you're walking down the street and somebody taps you on the shoulder and says, hey, what's a logarithm? What do you say? It's an exponent. So what's a logarithm? It's an exponent, okay? A logarithm is always an exponent. And if you think about it that way, it becomes a lot, simpler. So let's explore logarithms a little bit. I think it looks like my my text boxes got crunched here. Okay, this is what you need for now. You don't need any of the other stuff. So take a look here. I have an exponential statement here, right? It says 3 to the power of 2 is equal to 9. So here we know that the 3 is the base. We know that the 2 is the exponent, and then the value or the power is a 9, right? So I can write that in logarithmic form. When I write it in logarithmic form, the way it is written is the following: log base something, log base of 3. So this becomes the base of the log. And what is a logarithm? An exponent. So the exponent always becomes the answer of the logarithm. The value goes in here, right? So base exponent, and here we have log base of 3 equal to the exponent. That becomes the value. So let's take a look here. 2 to the power of 5 is what? 2 to the power of is 32, right? So here, where is the base? 2 is the base. Okay? So in here, let's write that in logarithmic form. To the right, log base 2 of 32. Now we need the answer to the logarithm. The answer to the logarithm is always an exponent, so that will be the 5. Okay? Now let's do it again. 4 to the power of 2 is 16. We know this. So here, it's going to be log base. you look at the base of your power, that's a 4. Now, the answer has to be the exponent, so 2. That means the value goes in here. Okay? So always think of it that way. Log base 4 of 16 equals a number. So log base, this is always going to be the base. The answer is always going to be the exponent. If you know that, log base, answer is the exponent, then you know where to put everything and you know where the value goes. So again, this is new to you, but once you've been doing it for a while, you look at this and you go, oh yeah, the exponent of 4 that would give me a 16 is a what? 2. Do you see how that's read? Okay, so take a look here. In here, right? Remember, logarithms are like, synonymous to exponential. So in here, we need to write now an exponential function. What's the base? Right, this is the base, right? 3 to the power of the exponent is equal to 27. Okay, do you see how it goes back and forth, right? Okay, so what's a logarithm? There we go, okay? You have to know that, just like you know your name. Like when you are, when somebody comes up to you and says, hey, what's your name? You don't have to calculate anything, right? You just know. So what's a logarithm? It's an exponent. Okay, so here it says to write each equation in exponential form. We're not solving anything, we're just rewriting in exponential form. So base, what's the exponent? 2. Exponent is 2 equals to a 9. Okay? And then it should be a correct statement. Okay, so Linoy, for this next one, what is the base? 10. And what is the exponent? Okay, equals to 1 over 100. All right? Okay, Maddie, in here, what is the base? 3. And exponent? 6. Equal to 729. All right? So now, the next few, we're going to write them in logarithmic form. We're not solving anything. We're just rewriting. So, to write in logarithmic form, we're going to have log base something. So, Caden, in this expression here, what's the base? 5. And then the answer to this has to be the exponent. So, what number goes in the middle there? 125. Okay? All right, Asher, you're going to help me out with the next one. Ready? All right, so log base. Base is what in this problem? 27. And what goes... Okay, so what goes in the first spot and what goes in the second spot? 1/3. So 1/3 goes here because that's the exponent and then 3. Okay, good. All right. Okay. All right, Samantha, let's do the next one. Log base C. Log base 6. Correct. Okay, so here's what we do. Always identify your base and your exponent. This is the base, right? So it goes in the spot of the base. Okay? What's the exponent? -3. That's the answer to the logarithm, right? And then what number haven't you used yet? 1 over 216. Okay? And then 6 to the power of -3 is 1 over 216. Okay, so these, we were just rewriting them. There wasn't really any computational math involved. Now it says to evaluate. Evaluate means find a numerical answer. All right? So when you evaluate something, you literally come up with an answer. 7, 3, whatever. Okay, these are questions that you are going to be required to do without a calculator. All right? Yeah. Now, on the notes, I have some things that, the numbers might get a little bit too big because there are a lot of options, but on quizzes and tests, they will be things that you can do, right? So for example, let's do this. Take a look here. We need the answer to this. This is a logarithm. We need the answer. What is the answer to a logarithm always? Exponent. Every exponent needs a base, right? So what's the base here? 2. So we're looking for the exponent of 2 that would give you an 8, which is what? 3. Okay? So you ask yourself, 2 to the power of what equals 8? And it's 3. Okay? So let's go underneath for a sec. 4 to the power of what is 64? 3. So this will be 3. Now again, if that's not immediately clear to you, that's okay. Like on the test, it'll be, stuff that you will definitely know. Okay? So let's take a look at this next, the bottom one. 1 over 9 to the power of what will give you 1 over 81? Squared. So this is a 2. You see that? What exponent of 1 over 9 gives you 1 over 81? Right, which is squared, right? So 1 over 9 squared is 1 over 81, right? 2. The final answer is 2. You just read the exponent, 2. Okay, so now take a look here. 25 to the power of what equals 5, right? So when you're dealing with logarithms, you always have to think exponent. I get it. You can divide 20. So the question is, how can you get 5 from 25? And I get it. You can divide by 5, but we're not looking at that. What else can you do to 25 to get a 5? Okay, you can take a square root of this, right? Right? How do you get from 25 to a 5? You can take a square root. So that's the same as 25 to the power of 1/2, right? That equals 5. So the answer here is a half. So logarithms have to do with exponents. And remember, roots are also exponents, okay? So now, take a look here. 6 to the power of what will be 1 over 36? Okay, so 6 squared is, huh? Okay, so 6 to the power of 2 is 36. But how do I make it 1 over 36? It's a negative, so -2. So how do I reason this? Right? Let's see, how do we reason this out? Well, here's what we do. I need to think exponents now. And it takes a little bit, right, to go with, to train your mind to just think exponents. So 6 to the power of what is 36? 2. And then when it's a whole number and a fraction, you got to do negative. Okay? So let's think about this again. Look, just look at the numbers, 6 and 36. Exponent of 2 will give you 36. But how do you deal with whole number fraction? Negative. Okay? All right, put your calculators face down for a minute, please. Okay, take a look here. What's the base? 10. 10 to the power of what is 100,000? Okay, when it's a deal with this, you have to count the number of zeros. How many zeros are there? 5 zeros. So it's 10 to the power of 5, right? So the answer here is 5. Okay? All right. So now we are going to do a little bit of okay.